we are looking at shortcuts to prove that two triangles are congruent. So yesterday we talked about having to have 6 parts of a triangle being congruent in order for your two triangles to be congruent. Today we are looking at only needing 3 parts of a triangle, of two triangles being congruent in order for your two triangles to be congruent. So we have 5 different ways to prove that two triangles are congruent with shortcuts. The first one is the easiest one to recognize. It is side, 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 meaning that all of your sides would be congruent to all of these sides in another triangle. So your picture would look something like this. You'd have one set of sides marked as congruent, another set of sides marked as congruent, and your last set of sides marked as congruent. So remember that when you have a side being congruent to another side, it's going to have a tick mark. Tick marks show that your sides are congruent. So if you have a set of figures that looks like this, where all of your sides are marked, that means that those two triangles are congruent. Okay, so that means triangles, and that means congruent. Next up, I don't recommend, if you have these copied in front of you, to draw on this figure, because otherwise you're going to be erasing a lot. Next up, we're looking at the word included. Included means between, or being made by. And this, it goes for both two sides, including an angle. So two sides making an angle, or it goes for a side that's included by two angles. So it's the side that's sandwiched in between two angles or being made by those two angles. Our first example here says that angle A, so this angle, is included between segment AB and segment CA. So notice how those two segments are making that angle A. Then we have segment AC is included between angles A and C. So again, notice that angle A and C are at the ends, and segment AC is the one that's being made by those two. So on our examples, we want to know what angle is included between segment AB and segment BC. So the angle that's being made by that is angle B. So if you don't have an angle symbol, you need to write the word angle out and then a capital letter B. Then we're looking at what side is included between angle B and angle C. So we have angle B, we have angle C, and we want the side that is being made by them. So that is segment BC, or segment BC. Then we have angle C is included between what two sides. So we're looking at angle C, and we want to know what two sides are being made by angle C. Well, we have segment BC and we have segment AC. making sure that BC and AC are capitalized. Then we're looking at what side is opposite angle A. So we're looking at angle A, and opposite means across from. In other words, not touching. So we want the side that's not touching angle A, which is segment BC. And last up here, what angle is opposite segment AC? So we have segment AC. We want the angle that is not touching A or C. So it's the one across from it. So that is angle B. Now on to our other 4 ways to prove that triangles are congruent. The first one is side angle side. So we have 2 sides marked as congruent and the angle that is made by those 2 sides, that's included between those 2 sides. So what that would look like, you'd have one set of sides marked as congruent, then you'd have another set of sides marked as congruent. And then you'd have an angle, and it's the one specifically in between those 2 sides. It's the one being made by those 2 sides. So if you look at it, we have one set of sides, and we have another set of sides, and we have the angle that is being made by those 2 sides. Again, when you have that, you know your triangles are congruent. So remember, we already talked about tick marks. Remember that arc marks, those curves in the corners, those tell us that angles are congruent. Then we have angle, side angle. So we have 2 angles and the side that is included by those 2 angles. The side that is being made by those 2 angles. What that would look like is something like this. So you have one set of angles marked as congruent. You have a second set of angles marked as congruent. And you have the side that is being made by those 2 angles marked as congruent. So again, you have one set of angles marked as congruent. You have a second set of angles marked as congruent. And that side that is in between those 2 angles, that side is being made by those 2 angles, is also marked as congruent. When that happens, again, you know that you have triangles that are congruent. Our next theorem is that we have angle, angle, side. So again, we have 2 angles, but this time our side is not being made by those 2 angles. So we'd still have 2 sets of angles marked as congruent, just like we did in the last one. But instead of being made, the side being made by those 2 angles, it's the one not being made by those 2 angles. So again, you'd have one set of angles marked as congruent, a second set of angles marked as congruent, and then you would have a side that is not between those 2 angles. And when that happens, again, you have triangles that are congruent. And then we have our last one, which is hypotenuse leg. And to me, this should really say hypotenuse leg plus a right angle. because the only way this one works is if you have a right triangle. So you'll notice that in our figures here, we have right angles already, and you have to have your hypotenuse, which is the side across from your right angle. And then you need another side, which is a leg of that right triangle. So the first thing you have to have here is a right angle. If you don't have a right angle, you cannot use hypotenuse leg. Then you need your hypotenuse, the side across from your right angle, and you need another side. When you have that, you know that your triangles are congruent. Now there are a couple things that I don't want to see on your paper today. The first one is angle, angle, side. Angle, angle, angle. This does not work. The reason it does not work is if you have two equilateral triangles with different size measures, they are still equilateral triangles, meaning that their angles are 60 degrees. But these two triangles are not congruent because their sides are different measures. So don't write down angle, angle, angle. The other one I don't want to see, because it does not always prove that your triangles are congruent, because you have a different side measure across from your angle, is side, side, angle. Don't want to see it. I don't want to see the reverse of that. So next up, we have two triangles that we want to prove are congruent. If they are, we need to tell why they are congruent. So notice that we have one set of angles marked as congruent, a second set of angles marked as congruent, and a side. So we have two angles. That automatically means I can get rid of side, 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 side angle, side, and hypotenuse leg. Now let's look at that last side. Now that side is being made by our two angles. So that means we have angle, side, angle. Next up, we have two triangles here. And notice that they are connected by a segment. Anytime you have that happen, you need to mark that segment as congruent to itself. Because it is. It matches itself in both of those triangles. Now, we have no angles marked, but we have all sides marked. So what do we have? We have side, side, side. Our next example, we have two sets of sides marked as congruent. So because we have two sets of sides marked as congruent, I automatically know I can get rid of the ones that have two angles and the one that has a right angle, because we have no right angles marked. Now, we either need another side or another angle, but we have to use what's given to us. Now, we don't have any information that tells us that the last side of sides is congruent, because they're not overlapping each other. They're not the same line. But we do have vertical angles. Please mark your vertical angles every time you have a picture that has lines that intersect like that, because those are going to be part of what helps you figure out what you have. So we have two sides with the angle that's being made by those two sides. So this is side, angle, side. Okay, then our next one, we have how many angles marked as congruent? We have one set of angles marked as congruent. So that means I can get rid of side, 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 angle, side, angle, 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 side. Do we have a right angle? No, so we can get rid of hypotenuse leg. Now we need to look and see where that angle is. So again, we have one set of angles, and we have two sets of sides. But is that angle being made by those two sides? Is it down here? No. This would be side-side angle. That means that it's not congruent. Our next one, again, we've got one set of angles marked as congruent. That means, again, that we know it's not side, 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 angle, side, angle, 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 side, or HL because we don't have a right angle. Now, are these sides making that angle? So we have one set of sides, and we have a second set of sides. Works on the left one, but it doesn't work on the right one. So that means that these are not congruent. Number 6. Is there anything else we need to mark? We need to mark that middle line, congruent to itself. And how many angles pairs do we have? One set. So that means, again, we don't have side, 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 angle, side, angle, 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 side, and we don't have a right angle, so it's not hypotenuse leg. So then we need to check and see where our sides are. So we have one set of sides, and then that second set is the one that we marked. We have side, angle, side on the bottom one, but we have side, side, angle on the top one, so these are not congruent to each other. Next up, we have one set of angles, a second set of angles, and a third set of angles. So this would be angle, angle, angle. Oh wait, what did I tell you? I don't want to see it because those are not congruent. Next up, is there anything else that we need to mark? Yes, there is. We need to mark that middle line. So we have our right angles, and we have another pair of angles, and we have a side. So how many sets of angles do we have? 2. So we can get rid of everything that doesn't have 2 angles. That includes hypotenuse leg. I don't care that we have a right angle. We have 2 sets of angles. So we have 2 sets of angles and one side. Is that side between 2 angles in one triangle or not between it? Okay, it's not between it. For those of you who are saying angle, side, angle, you are looking at 2 angles in 2 different triangles. You have to stick in one triangle. If you need to, cover up the second triangle. Our next one, we have a right angle. We have the side across from our right angle. And we have another side. So on this one, we can get rid of anything that doesn't have just one angle, which are those 3. We have a right angle this time though. Do we have the hypotenuse? Yes, it is marked. Do we have another side? Yes, it is also marked. So we do have hypotenuse leg this time. Make sure to ask yourself those questions and mark it. Mark anything that has a side like this that's the same between them. Mark any vertical angles. Remember, vertical angles are made by two intersecting lines. They look like that. And then ask yourself how many angles you have. Mark out anything that doesn't have the same number of angles that you have, and then go from there.